Hey, welcome back to my week 11 advanced financial modeling exercises. This week we were asked to create a comprehensive portfolio optimization tool that includes data collection and pre-processing for a set of stocks, risks and return calculations, efficient frontier visualization, optimal portfolio weights calculation, and performance comparison with benchmark indices. Indices. So as we can see in line number 1, import requests, import pandas, import numpy, import matplotlib, from datetime, import datetime, and from skippy.optimize, import minimize. For configuration, we're using my API key. So there's the API key, tickers, start date, and benchmark. Helper, fetch data from Alpha Advantage. That's where we fetch data, use the link for API. If time series daily not in data, then it will fetch the value error fetching data, time series data, same as always. So step 1, we have data collection. Collect data, tickers, df equals pd data frame, for ticker in tickers, temp equals fetch data, ticker. If df empty, df equals temp, else df equals df join. How equals outer. And then return df. Then for step 2, if we look at line 43, risk and return, def calculate stats, prices, returns equals prices, percent change, drop in a, mean returns equals return mean times 252, cov matrix equals returns cov times 252, return returns mean returns cov matrix. Step 3 is the portfolio optimization, def portfolio preference, weights mean returns cov matrix, ret equals np dot weights mean returns, vol equals np square root, np dot weights t np dot, return ret volt. Then neg Sharpe ratio, which is weights mean returns cov matrix, risk-free rate, which is 0.045. We have PRET, p-value, portfolio performance, weights mean returns cov matrix, and then return. And then finally def for this step 3, def optimize portfolio, mean returns cov matrix, number of assets, mean returns, args equals mean returns cov matrix, constraints equals type, ec fun, lambda x np sum x minus 1, bounds equals tuple 0 and 1 for in range number of assets, and then init guess equals number of assets times 1 divided by number of assets. Results equals minimize neg Sharpe ratio, init guess, args equals args. The method is SLSQP, bounds equals bounds, constraints equals constraints, and then we return results. For step 4, it's the efficient frontier. Def plot efficient frontier, mean returns cov matrix number of points, which equals 100. Results is returns and volatility. For in range number of points, weights equals np random. Ret vol equals portfolio performance, weights mean returns cov matrix, results appended. Results volatility, to show the volatility. Plot figure size 10.6, plot scatter, results volatility, results returns, plot label volatility, plot label return, plot title efficient frontier, and PLT color bar is Sharpe ratio. BLT grid is true. So this is for our first visualization. Now if we look at step 5, starting at line 86, it's benchmark comparison. Portfolio returns equals prices, percent change, drop in a at weights, portfolio cumulative 1 plus portfolio returns, SPY equals fetch data benchmark, SPY equals SPY index, SPY equals SPY rename columns, benchmark SPY fill, benchmark returns equals SPY, benchmark cumulative equals 1 plus benchmark return, combined equals PD data frame, portfolio cumulative, SPY, benchmark cumulative. Combined plot, the figure size is 12.6. Title, portfolio versus benchmark. Plot label is growth of $1. Plot grid is true, and plot show. This is for our other visualization. And then the main execution is def main, prices equals collect data tickers, returns, mean returns, cover matrix, calculate stats, prices, opt result equals optimize portfolio, mean returns, cover matrix, weights equals opt results X. Then we print optimal weight for T, W, and zip tickers weight, print what those are. And then rep vol portfolio performance weights, sharp rep minus 0.45 divided by volume. Then we print the expected return and the percentage and volatility in that percentage and Sharpe ratio. Then we plot efficient frontier. And then if name equals main. Now looking at our terminal, we can see what we just coded in the main execution. We can see optimal weights, sorry about that. AAPL equals 0.00%. Microsoft was 100%, and then Google and Amazon were also 0.00%. And then expected returns was 5.54. Volatility was 27.48, and Sharpe ratio was 0.04. So now looking at our first visualization we created, figure 2 is first. Growth of $1 is the label, and the entire graph is named, the title of the visualization is portfolio versus benchmark. We can see portfolio in blue and the SPY in orange, just as we coded. And then for our second figure, which is actually figure 1, sorry about that. Efficient frontier is the title of our visualization. We have returns and Sharpe ratio and volatility. You can see all the scatter plots or plots on this graph. And then the sidebar indicating Sharpe ratio by the color. Thank you so much for watching my week 11 video. I hope you enjoyed, and I'll see you next week.